Good morning. Welcome to the last webinar in our spring and summer webinar series. Today we are going to talk about the results of the Barcelona pilot. I will wait a couple of seconds for people to arrive. Thank you very much for those who join us online. Um, For those who would like to review specific segments, the webinar will be made available on YouTube, also with timestamps and chapter marks. And if you have specific questions, please ask them in the chat. My colleague and I from Polis will monitor the chat. So my name is Miklas Malotz. I'm the communication manager of the NextETRUCK project, and I will give you a brief project overview and give you some suggestions what kind of events you could attend in the upcoming month. And then we will have a NextETRUCK pilot and vehicle upgrade information from Irisa, and then we will have a detailed overview of the digital twin application that was used at the Barcelona use case, and then we are talking briefly about the results and uh, the overall updates are going to be provided by Inigo Laman from Irisa, and the digital twin elements will be presented by our colleagues from Techlania. So, NextETRUCK stands for Efficient and Affordable Zero-Emission Logistics through Next Generation Electric Trucks. That is quite a mouthful, but this can be summarized in medium-sized trucks that are operating in urban and peri-urban environments. And we had three pilots. On the top, we see the pilot vehicle from Ford Otosan, and on the bottom, we see the pilot vehicle from DAF. They operated in Istanbul and the UK, respectively. And the middle is our beautiful refuse truck that we have presented in Barcelona, and that will be the focus of our 1 hour webinar today. And the main innovative aspects of the project are several innovations related to drivetrain technology, the development of digital twins that we're going to listen to today. And then we are going also talk about the optimization of the vehicle design, which was one goal that was definitely achieved with our vehicle. And also last week we have talked about the cost calculation tools that are very important for freight companies if they want to overhaul their fleet and electrify their fleet. This was presented in our last webinar from Xenix. And so here we can see again the pilots. And here is a nice overview of our use cases, the pilots, and our key innovative aspects. So we are basically coming to the end of the project, and therefore we are also celebrating our NextETRUCK final conference, where we celebrate the deployment of the medium-sized electric trucks across Europe. And this final conference will take place on the 28th of September in Brussels, basically as part of the Connecting Europe Days. And this is a joint event that is organized by DAF and Ford Otosan, because these are probably going to be the vehicles that are going to be displayed there, and by us from Polis. And if you would like to receive further information and updates of project results beyond the Barcelona pilot, you can find us on LinkedIn and on our website by scanning the QR codes or by searching NextETRUCK on LinkedIn. And with that, I would like to give the floor to my colleague Inigo for his introduction.
Thank you very much, Nicholas. Let me share the screen on the presentation.
And while you're sharing the screen, please, the audience, don't forget to ask your questions in the chat for me or for Inigo or the other colleagues.
Okay, great. Thank you very much, Nicholas. I'm Inigo Larman. I work as a product engineer for Irisa. In Irizar, I'm specialized on the electric truck division. First of all, I'd like to start by introducing what Irizar is and what our company does. We are a company based on Spain, and we were founded in 1889, so we are almost 140 years old. We are a group consisting of six different companies throughout Spain, and we also have divisions in other countries, mostly in Europe and other countries. And we employ worldwide almost 4,000 people. And in terms of revenue, for example, in 2024, we had 1,000, about 1,000 million euros of revenue, just to have an estimation. In terms of locations, our headquarters are located in the north of Spain. This is where most of our companies are located. However, we do have some companies like Hispacol in the south of Spain, and in the east of Spain also we have another company called Massats. We also have manufacturing plants in different countries of the world. For example, in Mexico, we have a manufacturing plant that manufactures buses. In Brazil, also we manufacture buses, and also in Morocco. Irizar is a group. We not only manufacture buses, that would be our main business, manufacturing buses and coaches. We also have inside Irizar our sister company, Irizar E-Mobility, which specializes only manufacturing electric vehicles and electric buses. Already mentioned Hispacol. Hispacol manufactures a lot of cooling and heating equipment used throughout the industry, mainly focused on the transportation and rail industries. Massage also does electrical and pneumatic door applications for our different buses and use cases. Gemma is another company of ours prioritizing power electronic development, electric chargers, um, photovoltaic applications, smart grid, etc. And finally, inside the ITAR, we have Grid Creatio, which is our research and development center. Some of the different historic milestones that ITAR has had throughout the years in up until 2009, well, ITAR was a bodywork manufacturer. We would purchase the chassis of different bus manufacturers, and we would install and design and install the bodywork. However, after 2009, we started designing and manufacturing the complete bus package. So we started doing our own buses and coaches. In 2013, we started our electrification journey, and we manufactured our first electric urban bus. And in 2016, we created Irizar E-Mobility, a separate company from the Irizar headquarters, the Irizar scope, that is entirely focused on manufacturing electric buses. On important note, we built a manufacturing plant in the north of Europe, uh, just for manufacturing electric buses, and we were the first manufacturing plant of Europe uh, only devoted to electric buses. Um, in 2019, a new opportunity emerged of some different projects, and we developed our first electric truck. So in 2019, we developed and deployed the first electric trucks in Barcelona, and in 2024, we kept after the experience we had in Barcelona, we kept improving on those learnings, the product, and we developed the second generation of our electric truck. This is a summary of the product range that we offer in Irizar. As you can see on the left, these are the long-range buses, mostly offered in diesel, hybrid, and natural gas technologies. But we also offer some of the long-range buses in electric powertrain technologies. And on the right, these are our city buses, which are 100% electric, and our electric truck, which we also offer in hydrogen, as we have a prototype with a fuel cell truck. Again, this is a closer look at our fully electric uh, fully electric portfolio. And now let me focus more on the electric truck, since this is the main focus of the NextETRUCK project. So the Irizar electric truck started as a project as a refusal collection truck. Here, work in collaboration with FCC, which is Spain's biggest refusal collection private company. They operate all over Spain, and they have most of the contracts with different cities. So it was a big partnership between Irizar and FCC, and that's how the electric truck project was born. Here you can see one of the first demo prototypes of the Irizar electric truck uh, running in San Sebastian. The truck started as an urban truck. However, what we develop, it's not just waste collection trucks. We develop a platform that can be adapted to different use cases. For example, in these pictures, you can see a different use case, which is freight transportation, because this is the second generation truck. And what we, at the end of the day, what we develop is the cabin and all the chassis with all the powertrain, and we partner with different body manufacturers to accommodate to our customers' needs. Um, as I mentioned before, this is the second generation electric truck. In the middle, you can see the first generation, which is the generation is the truck we used for the NextETRUCK project, and some of the improvements we developed for the second generation are fast DC charging of up to 360 kilowatts. We offer two types of battery technologies, either Gen Z NMC for the maximum energy density, or LFP batteries. And with this second generation, we reduced the overall vehicle weight over 1 ton, and we also made it more efficient, so the range was bigger with the same battery size. Here we can see different second generation Irizar trucks in different use cases. For example, urban transportation of goods. They can be cooled or at ambient temperature. As I mentioned, uh, one of our strong cases is that our platform is very adaptable. For example, here we can see a use case where we can transport liquids such as a fuel tank, water, transportation of people with special needs, propane, etc. So our platform is very adaptable to different use cases and needs. And here you can see pictures of real trucks that we develop and that we have already manufactured and are already in operation with different applications. Here you can see more pictures of different applications. For example, this truck is a refusal truck that's working in Switzerland. This is a truck working in San Sebastian. This one's a refusal truck working. This one's one of the first generation trucks that we started working in Barcelona. more Barcelona trucks with different body configurations. Okay, so what are some features of our electric truck? It's 100% electric. It was built from the ground up to be electric. We didn't take an existing diesel truck. What we did was design from a truck from zero, taking into account that it'll be electric. So we have optimized everything for the electric mobility. And also, we took the same technology and architecture that was already being used in our electric buses. So our truck technology has been tested and validated over 1,500 electric buses that are currently operating all over the world. One of our key features of the truck is the low access height. In traditional trucks, the driver has to climb several steps to get into the cabin. However, taking the same philosophy as the buses, we designed a cabin that is very low to the ground, so the operator can get into the cabin with just one step. This is very useful, especially in refusal operations, because the drivers have to get in and out of the cabin a lot of time, and this can reduce a lot of injuries because of falling. So this is one of our key advantages, and in fact, we have the lowest access height of the market. Since the cabin is very low and it's all glass, the view is very good, and it has over 200 degrees of field of vision. So it exceeds what traditional truck manufacturers delivering the products, because their cabin is higher and their degrees of vision would be lower. Also, one of the key aspects of our truck is the maintenance. In traditional trucks, the entire cabin has to tip over to access the motor and powertrain components. However, our cabin stays fixed, and we have big side access doors where a person can get inside and access all the components for easier maintenance, and thus having an easier maintenance and lowering the total cost of operations. One of our key advantages is also the energy management storage. We develop in-house the battery technologies that we integrate in our trucks. All the NMC technology batteries are developed by Urizar and are also assembled here in the Basque Country in the north of Spain. So we control all the supply chain from start to finish in the batteries, which is one of the most important components for electric vehicles. We also offer charging solutions. Our partner Gemma, which is part of the Urizar group, offers different charging solutions. Our truck can charge either in AC mode or DC mode, on up to 360 kilowatts. So we partnering with Gemma, when we sell or deliver trucks to different customers, we can sell them as a package, both trucks, including charging infrastructure. Here you can see some of our trucks using our charging infrastructure supplied by Gemma. And to finish, some use case examples. For example, this truck is in Paris, which is a bridge truck. This one is in the north of Spain, a official truck, a more official truck. This one's working in Switzerland, in San Sebastian. This is working in France. Okay, now let me introduce our partnership with NextETRUCK and our involvement with the NextETRUCK project. So I'll show first a video we took with the Barcelona use case pilot.
This is a common problem that the audio is not being transmitted. So maybe we can show it at the end again. Um, because we can't hear anything and the connection is not it's not perfect.
Oh, the connection is not good. Okay.
But yeah, we can maybe show it at the end
Yes.
again. And we can check the settings while we look at the other presentations because it demonstrates the use case really well.
Okay, no problem. Yes. Let me continue. Okay. You can see the screen, right?
Yes, all good. Perfect.
Good. Okay. Okay. So some of the track features that we deployed in Barcelona for the use case of the NextETRUCK. It's a first generation Ether truck that was already working in Barcelona. It has a 4x2 drivetrain. So this means two two axles and one driven axle. It's an M3 category, which goes from 16 tons unloaded of and up to 20 tons loaded. The configuration of the bodywork, it's a tipper open box. So as you can see, for unloading the box can tip, and also it has here a hydraulic powered crane to pick up heavy objects and place them inside the open box. What we did is take this existing truck that was operating in Barcelona, and we updated the hardware with different improvements and innovations that we developed for this NextETRUCK project. One of the main upgrades that we performed was update the NMC batteries that it had, and we updated it to our latest generation, which is the third generation. Um, this change improved massively the range of the truck because before we had 170 kilowatt hours of energy with the baseline truck, and after the upgrade, we improved an 80% in onboard energy, uh, going up to 307 kilowatt. This means that these new third generation batteries they developed in-house by Richard. They provide a 62% increase in energy density, and also the number of batteries. Before we had four battery pack units for the baseline truck, and with these new batteries, which provide more energy, we only needed three battery pack units. However, since these battery packs have more cells and they are more densely packed, we did increase the total weight of the batteries about 175 kilograms. However, this increase in weight it was well worth it because the energy increased in over 80%. One of another change that we performed on the hardware of the truck was changing the HVAC and BTMS system. The HVAC is the system that is in charge of cooling and heating the cabin to have for the comfort of the drivers. And the BTMS is the battery thermal management system. This system is in charge of cooling and heating the battery. Before, as you can see in this picture, on the baseline truck, we had two separate, the BTMS and HVAC were separate in two different units. And we developed a new technology, a new unit which combined both separate systems into one, which you can see the final integration on the right, which combines both systems. And what's the advantage of having two systems in one? Well, first of all, the number of parts is lower. Before, we needed two compressors for cooling each system. Now we have one shared compressor which is enough to power both systems. Uh, this means that since we have a lower just one compressor, the energy consumption, the thermal energy consumption will be lower. And also, the weight decrease around 60% thanks to the integration of just a single system. Another innovation that we introduced was the digital twins for the BTMS control. These digital twins were developed by Tecnalia, and our colleague Beñat Arteta will talk about the details of how they developed this innovation for the project. So I'll give the stage to Beñat now so he can tell us more details.
Okay, thank you, Inyo. So let me 1 second, please, to share my screen with my presentation, and I will start my presentation. Okay, so uh, let me know if you can see my screen.
Yes.
Okay, so this is Beñat Arteta from Tecnalia speaking. I will present the work that we have been doing in the NextETRUCK project with collaboration with Irisar. I will start with a brief presentation of my company Tecnalia, and then I will carry out with the introduction, the objectives of the project, and what we have been working on during the previous months. So, as I said, this is Tecnalia, one of the largest research and technological development centers in Spain, member of the Basque Research and Technology Alliance, and in the unity where I work, we work in making the transport of the future more sustainable and looking for new solutions for the mobility industry. These are more or less the areas of expertise of the group. We work on the electric, hybrid, and powertrain control. For this, also we work generating new hardware designs for the control targets, for example. Also, we have been working the previous years in battery management systems, getting new solutions for operation variables of batteries. And with all of this, we have been implementing all the solutions using methodologies as the hardware in the loop and digital twins. So more specific, I am specialized on digital twins and model-based design based on mills, seals, hills, or online now also online real-time digital twins. Such as in this project, and for this also cloud-based data logging, computing, and monitoring solutions. So with this, a brief introduction of what we have been working on within the NextETRUCK project. From Tecnalia side, we have been working with Irisar in the digital twin and of the vehicle, and more specific for the Barcelona use case. So the objectives from our side was to reduce the truck energy consumption, and more specific, we have been focusing on the auxiliary systems in the battery thermal management system, and to get that energy reduction, what we have been analyzing and then developing was to get an optimum battery set point temperature. So this is the solution that we have been working on, which is the cloud solution for the connected vehicles. In this case, we have two separate aspects. in the right side, we have the utilised demo, in which we have a IoT dispositive through a firewall connected to the vehicle CAN, and also a DATIX data logger. And in the left, we have what we have been working on, the cloud environment. Let's say we have three different points for the route information, developed by different partners such as NNG, and also we have the energy consumption digital twin developed by AVL. I think that Michael is also in online in the webinar, so maybe if you have more specific questions, you can ask him. And we have this bigger panel in which we have developed a Technalia server, in which we have created two different blocks, one for the multi-level digital twin and another one for the cloud smart VTMS. And the communications between two parts are made through 4G and 5G connections. So if we go more specific in this solution, what we have been working on is a Technalia server called Katea. This has inside an MQTT broker for the connections with the vehicle through the IoT dispositive, getting the communications 5G or 4G, and also inside the server we have an FMU orchestrator for the connection and the operation of different digital twins. And as I previously said, this is connected through also communications 4G, 5G to the energy consumption digital twin developed by EVL. So from one side, we have the multi-level digital twin, in which we have developed and modelized the different components of the vehicle. We have in one at the top the ECUs, such as the TCU or TMS. We also have different FMUs for the driver and the vehicle, different and separate FMUs for the powertrain different components, batteries, electric motors, inverter, transmissions. And at the bottom, we have the thermal system, the battery thermal system and the battery management system. This solution allows us to make a flexible and modular digital twin solution in which we can create different models with a desired level of fidelity. So for this solution, we have been doing the powertrain models FMUs with a lower medium fidelity, and the thermal models with a high fidelity level. So this is the smart VTMS for the part of the thermal system of the vehicle. This solution have been carried out with the collaboration of NextETRUCK, which has developed the VMS and the battery FMUs, and the VTMS and the battery thermal system we have developed internally with collaboration with Irizar. And with all of this, we have created the FMU standard for the co-simulations of the different components, and also the reduced order model ROM for the cloud execution availability. In this ROM, what we have applied is a IA solution with neural state space algorithm, in which we have power, shock, and the coolant temperature as the inputs for the ROM model. And with all of this, what we get as an output is an optimal battery temperature. This development has been validated in two stages. First of all, we did it in hardware in the loop solution, integrating the multi-level system control and the thermal system models uh, inside the real-time solution or machine that is the speedcode from MathWorks. And once we validated in the real-time machine, we did same validation in the cloud server of Tecnaria Katea. For the validation stage, we did a calibration phase in which we have to take into account the time, the execution time that is required for the solution. We have established the data transfer between the vehicle and the cloud in 5 seconds, the FMU's execution in 60 seconds, sorry, and the call for the predictive information to the AVL's energy characterizations data twin also in 60 seconds, and the total FMU execution time horizon in 300 seconds. So once we have calibrated all these different phases, we have reached to those results. So we have here two different images. In the left side, we can see the Barcelona Lucky profile used as an input for the solution without an optimal battery temperature set point. So in this graph, I don't know if the quality is good enough to check it out, but in this graph, we have here the BTMS, the compressor power electric power used. We can see that more or less the maximum power required is around the 1,000 and 300, sorry, and it's activated more or less in 300 and a half seconds. And in the right side, we have the same profile from Barcelona use case, but in this case, we are using this optimal battery temperature set point. So in the same graph, we can see that the compressor is activated later on in x-axis, that is the time of the drive cycle. It's now activated around 650 seconds later, and the maximum point of the power electric is less. So with this, we conclude that using this optimal battery temperature set point will reduce the consumption of the auxiliaries, such as the battery BTMS system. We consider part of those auxiliaries. So when we finish the validation part on the hill and the cloud, we integrate all of this in the vehicle, in the EDSAR's vehicle in the use case, having in one side the logistic planner to know the route and the AVL characterization for the power prediction of the vehicle in that specific route. We have executing Katea Tecnaria server, which does a prediction of the optimal battery temperature that goes through inalámbric communications, 4G and 5G, and enters in the vehicle through the IoT dispositive. And in this case, the final results of the operation is gonna be my colleague Ingo from Irizar, who's gonna explain it. So this is all from my side. Inigo, the floor is yours. Maybe you can explain further the vehicle generating results.
Okay, thank you very much, Viñat. I'll continue with the presentation. Okay, so yes. So Beñat was talking about the digital twin that was being executed on the cloud server and how the truck would communicate with its servers. And one of the devices or the input devices that the driver could communicate with these digital twins was the IoT-based navigation. We integrated this tablet, which one of the partners of the project, Third, they developed an app that would give navigation based on the routes that the drivers could follow that day, and this route information would be sent to the servers where the IoTs would use this route information. And this tablet was the I guess the human interaction with these digital twins. Another change that we performed in the Barcelona use case, Barcelona in FCC, the refusal company that would operate this truck already had several electric chargers. However, these were only 50 kilowatt chargers. For this project, one of the innovations was about electric chargers, and our partner Gemma installed 180 kilowatt chargers. So more than 3 times the power capability of the original chargers, and also these new chargers had data logging capability to record all the charging sessions, the energy used, etc. Talking about the operations in Barcelona, the truck operated doing bulky waste collection. This is refusal. This is things like old sofas, fridges, etc., that are left in the streets of Barcelona at different pickup points, and the truck goes to these specific pickup points when it is needed, because the town hall receives a call or the FCC receives the need to pick up these to go to these pickup points, and it mainly operates in the night shift. The length of the distance of these journeys, they've been around from 60 kilometers to around 110 kilometers, and the duration of the Barcelona pilot was 6 months, where we collected all the data of the operations and compare it with the baseline truck, which we already had data to have as a reference point. Here you can see on the left a real example of one of the routes that it performed, uh, which the pickup points are all located in the city center of Barcelona, and the truck goes to the south of Barcelona to dump all the waste to a recycling center. And on the right, you can see a heat map of the 6 months of operation of all the streets that the truck visited and the most frequented streets. And as you can see, it covered a big part of Barcelona's city center. Talking about different metrics and operational uh, KPIs that we measured during the operation. Looking at the data, what we saw is quite a high variation on the route distance. As you can see on this first chart, these are the kilometers performed each day. And as you can see, there's quite a lot of variation. And this is explained, and this is normal, because this bulky waste collection, some days you can have a lot of pickup points, and some days the pickup points are fewer. So this explains the high variation in the distance covered each day. Regarding the daily battery energy consumption, we've seen that is proportional to the distance covered. So longer distance, we've seen a proportional increase in battery consumption. Regarding the efficiency, here you can see the evolution of the efficiency throughout the months, taking into account that the demo started operating in September and it finished in March. We've seen that, well, in this pink graph, you can see the evolution of the average ambient temperature in the night shift of Barcelona. As you can see, in September, it started in a hotter weather of around 25 degrees Celsius, and in winter, the median temperatures went down quite a bit to about 12, 10 degrees Celsius. This is an important point because we've seen a big correlation between overall efficiency and uh, ambient temperature. In lower temperatures, such as the winter months, we've seen that the efficiency has decreased. This means when the green graph goes higher, this is the kilowatt hours per kilometer is higher. This means that the truck is consuming more energy. And we've seen in winter months that the efficiency or the consumption is bigger. And this is explained because in winter, the batteries need to use energy to heat up these cells. And this energy is used, this is extracted from the batteries. And this means that the efficiency is low. In contrary, in September, the weather was hotter, and we can see here clearly that the efficiency is better. One of the key points of this efficiency was the BTMS digital twin control that Beñat already explained. Since this here you can see a snapshot of a chart during the Barcelona operations, where the blue line was the temperature goal that our traditional electronics was sending to the BTMS, and in orange you can see a higher set point temperature sent by the IoT device by Tecnalia. So since the temperature set point was higher during the operations, we saw a decrease in cooling energy consumption. So one of the reasons of the efficiency increase was thanks to this digital twin integration. Regarding the efficiency and comparing it to the baseline data, what we did on the left, you can see some data, the data we collected on the baseline vehicle, and on the right on the demo vehicle. I took the same, since the efficiency was so dependent on ambient temperature, what we did is compare the same time period with a similar ambient temperature. For example, the baseline data, we have the data from May 2024 to July 2024. So it operated in spring and summer months. So we had a median temperature of around 24 degrees for the baseline. And I took the September to end of October period of the demo data, where we had a median ambient temperature of around 22 degrees. So we could compare similar ambient temperatures. And what we saw is that the demo had an overall efficiency improvement of 7.5% comparing with the baseline data. Regarding the overall energy breakdown, here on the top chart represents the baseline energy breakdown. The bottom chart represents the overall energy breakdown per system for the demo. And what we saw is that traction energy, the energy used by the electric motor, accounts for 71% of the total overall energy. So also the PTO is the small electric motor that is used by the crane and the tipping system. We saw very little use of the PTOs, so very a few minutes per shift. So this explains why the PTO use was less than 1% of the overall energy. Uh, Regarding also, as I mentioned in the previous slide about the efficiency, uh, during the winter months, we saw a higher use of BTMS heating consumption during the demo due to the colder winter nights. And in the demo, thanks to the new BTMS integration, we saw a decrease in low voltage consumption from 19% to 12%, thanks to the new BTMS, which is powered directly by a high voltage battery instead of the low voltage systems. And finally, to summarize all the improvements that our client FCC and the impact that this project has had over this existing truck, we saw a decrease in consumption of 7.5%. We also increased the range of for more than 95%. So in the original truck, it could do around 180 kilometers, and with these new batteries and the decreased energy consumption, it can do around 350 kilometers. And these two improvements means a reduction of total cost of ownership thanks to the lower energy consumption. So this means that the operator will use less energy charging the trucks. Also, the reduced maintenance cost since the new VTMS has less parts. It's newer, and also we renewed the battery, so the cells are new. So the battery has over 10 years of useful life. So this we estimate a 15% of total this year. And also one of the big improvements is charging time. Before, with the original chargers, our customer would need around 5 hours to achieve 80% total energy. However, with this new fast charger, we can achieve the same state of charge in just 1 hour and 20 minutes. So that's over 70% improvement in charging time. And with that, I hope everyone enjoyed this presentation. And please feel free to ask any questions if you have doubts or you want to ask anything regarding the Barcelona pilot.
Thank you very much, Inigo. This was very, very interesting. And also, this was, at least for me, the first time that I saw these numbers, the results, basically. So when we look at the lower TCO and the significantly increased range in comparison to the baseline that we have expected in the beginning of the tests, um, did the operator say anything about the performance of the vehicle and the crane, or the usual day-to-day operation? Were there any problems, or was it?
No, yes, no, in fact, the operator was quite happy because the new batteries turned out very well. We didn't have during the 6 months any breakdowns. The truck operated without stops, and we didn't have to do any services or it didn't malfunction. So the operator was very happy with the improvement, and also they were very happy with the range improvement. So with these new batteries, this means that in theory, they would be able to do 3 consecutive shifts without charging. It is true
Yes.
that with the current necessities, they only do 1 shift per day, but now this has brought the opportunity to do consecutive shifts. So they are quite happy about this.
I have another question, which is a bit which is a bit mean because it is a bit hypothetic for
Yes.
you. Um, w- did you talk to the operator, and do you have any idea how this would continue for the use of such vehicles because the performance of the battery and the entire system is enhancing so much. Do you think that they would use then preferably smaller vehicles or smaller and lighter vehicles to because for daily operation the vehicle is basically overperforming, I guess.
Yes, it's true.
Theoretically, you could put a smaller battery in there and make the vehicle lighter, and then charge daily, I assume, right?
Yes, true. Regarding these particular operations, they could lower the cost of the truck by installing a smaller battery,
Yes.
and this would mean that it's a lower cost for them. However, um, in the case of Barcelona and FCC, they have a fleet of about 10 EV electric trucks, and it is very small compared to the entire fleet because they have over 300 trucks just in Barcelona, and those are powered by a combustion engine, which those combustion engine trucks they perform several shifts consecutively, and up until now, because the electric truck and this technology was new, they wanted to be safe and just perform one shift per day. But it is true that now that we have proven that this technology is capable of doing more than just one shift, I think they can start transitioning and using less their combustion engine trucks and doing more shifts with these electric trucks, because it is true that they have to lose the and not be afraid of at the beginning. It's true that maybe they are afraid of not having enough range, but after these types of demos and real use cases, it is proven more than enough that these trucks and this technology is capable.
Um, Last question, which is also looking into the future, maybe a little bit. Do does the operator already have plans to electrify slash decarbonize, or because these results just came in, it still requires a little bit of planning?
Yes, in fact, one of the challenges we have, especially in the electric truck sector, is that usually, if you compare the price of a combustion truck compared with an electric truck, usually the initial cost acquisition of the electric truck is about twice of a combustion truck.
Hmm.
So a lot of times this is a challenge because the operators, unless they are incentivized by public aids or government help, they usually go with combustion trucks because they can buy a bigger fleet for the same amount of money. But it is true that now, with the introduction of different restrictions to in the city centers for having greener vehicles and the increase of help, financial help by local governments, we do see an incentive and an increasing demand of these kinds of vehicles. Because it is true that in electric buses, electric mobility is more established, but in
Hmm.
the truck sector, I think it's still a little bit behind compared to the bus sector.
Yeah, that makes sense, and that's why projects like NextETRUCK or other projects of the Alveto cluster with whom we are also cooperating are very much important to showcase that real world long-term daily operations really work very smoothly. So thank you very much to all of the speakers. This was a fantastic insight, and basically, if you, the audience, would like to learn more, please don't miss our final conference, as I was mentioning, which will take place end of September, and which also conclude the other pilots basically. So we have similar use case in the United Kingdom and in the outskirts of Istanbul with DAF, and respectively Ford Otosan. Thank you very much to the presenters, and I wish you a great day and hopefully to see you in Brussels. Thank you.
Thank you very much.